Hey guys, Mr. Backerberg here. In this video, we're going to take a look at even and odd functions. When we're talking about even functions, a function is even if f of negative x is equal to f of x. Visually, what that's going to look like, a good example of an even function is y equals x squared, this parabola shape. If we look at points located along this parabola, so say we've got this general point x, y on the right-hand side of our parabola, there's a matching point directly across from it, which is negative x, y. So those x values are opposites of each other, but the y value is exactly the same. When we're looking at the equation y equals x squared, let's say we wanted to plug in 2. Well, 2 squared is 4. But now let's talk about doing the opposite of x. So if we wanted to plug in negative 2, negative 2 squared is also 4. So having f of negative x being equal to f of x means that when you plug in opposite x values, you get the exact same answer. Now, because of those matching points, what's happening is this right-hand side is being reflected over the y-axis. So we can say that this graph has y-axis symmetry. When we're talking about an odd function, a function is odd if f of negative x is equal to the opposite of f of x. And a good example of an odd function is y equals x cubed. So we can see on the right-hand side, we've got this general point x, y, and down across from it, we've got the point negative x, negative y. So it's the exact same numbers, they're just opposites of each other. So if we look at that equation, y equals x cubed, and let's do similar to what we did on the previous one. If I plug in 2, 2 cubed is 8, but if I were to plug in negative 2 cubed is negative 8. So we plugged in the opposite x value, and we got the opposite of the original answer. So again, same exact numbers, 2 and 8, but they're opposites of each other, negative 2, negative 8. This type of relationship with the ordered pairs graphically gives us something that has origin symmetry. So what we're going to do in this example is algebraically verify that a function is an even function. So we're given the function f of x equals x squared. And what we want to do within this function is we want to plug in negative x. So we want to look at f of negative x. So what that means we're going to do is in our function, we're going to replace the x that's in there with negative x. Now we're going to go ahead and simplify this down. When you square something that's negative, it ends up giving you a positive result. What's really happening in here is we're taking negative x times negative x. And those two negatives cancel each other out and turn this back into positive x squared. Because we're getting the exact same thing that we started with when we plug in that negative x, that algebraically verifies that this is an even function. Now let's look at what happens if I change that function just slightly. So instead of just being x squared, now I put that plus 1 on the end. I'm going to run the exact same test. I'm going to look at f of negative x, and I'm going to see what happens. So I replace the x that's in that function with negative x, but I still have to square that, and then I'm going to add 1. Well, squaring this negative x gives us a positive x squared, and this plus 1 stays as a plus 1. So again, the answer that we get when we plug in that negative x is exactly the same as the function that we started with. So yes, this function is even as well. Now, instead of looking at an even function, let's talk about an odd function. We're going to run the exact same test. We've got f of x equals x cubed. We're still going to look at f of negative x. But this time, when I plug the negative x in there, when you cube something that's negative, you get a negative answer. And what I want you to recognize about this one is this answer that we got is very similar to the original, but it's actually the opposite of the original function. And that's what makes this function odd. Now, if I change this function slightly by putting that plus 1 on the end, let's run our test that we've been running. So looking at f of negative x. So if I plug in that negative x and then cube that and then add 1, Well, cubing that negative x gives me a negative x cubed. Negatives cubed stay negative, and then I've got that plus 1 on the end. If our function was even, this would go back and match up with the original function that we were given. But this one doesn't match up, so it's not even. If it was odd, then it would be the exact opposite of that original function. But the opposite of this function, if I do the opposite of x cubed plus 1, and I think about distributing that negative in, I'd get negative x cubed minus 1. So this one is not the opposite of that original function either. So that one's not odd. So it is possible for a function to be neither even or odd, which is what we've got happening here. That's going to be it for this video. Thanks for watching.